Um, we are going to be using synthetic division again. Uh, just as a reminder, when does synthetic division work? When you have a single root in the bottom and it's not a fraction. Now that's not totally true. If my denominator was 2x plus 1, then synthetic division isn't going to work. It will work, but it'll end up being, the equation you get will be larger than it needs to be. But if I have, say, x minus 1/2, that actually will work the right way. So really, if the denominator has a single root and this number is a 1, synthetic division will work. Okay? An interesting thing about dividing polynomials, if I had x to the third plus 6x squared minus 4x plus 2, and I'm dividing by, say, x minus 1, so what number do I put in the box? 1, and then I put 1, 6, negative 4, and 2, and I drop the 1, 1, 7, 7, negative 3, negative 3, and 1, negative 1. Okay? Negative 1 turns out to be the point on the graph of the original numerator when x equals 1. So if I were to graph this, which is some kind of x to the third equation, when x equals 1, y equals negative 1. The remainder is the value on the graph at that value. So 1, negative 1 right there. So the remainder is the value you get when you plug in that particular x. It's the y value you get when you plug in that x. So if this numerator was f of x, then f of 1 is negative 1. When x is 1, y equals negative 1. Which is why, when you get a remainder 0, you end up with a simplified equation that doesn't have a fraction in it because it went in evenly. Okay, so we can actually use synthetic division to find roots of polynomials that are bigger than quadratics. We know how to factor quadratics, and there's one type of cubic equations we know how to factor, but most of them we don't know how to do. In fact, I don't even know how to do it, because it must be harder than the way we've learned. But what if it's an x to the fourth, or an x to the fifth, or an x to the sixth? How do we find all of the roots without graphing? Well, you use division. So today, we are going to take a polynomial, for instance, x to the third plus 3x squared minus 10x minus 24. How many roots does that have? 3. And I'm going to tell you that one of the roots is x equals 3. So I know that x equals 3 is one of the 3 roots. How do we find the other 2? I'll tell it to you. Yeah, it's given. What we need to do is synthetic division using 3. When I do synthetic division using 3, I know that the remainder is going to be 0, because the book is going to tell you this is a root. So I put 3 up in the corner. And am I missing any x values? I don't need placeholders. So 1, 3, negative 10, and negative 24. Drop the 1. 3, 6, 9. Oh, did I do something wrong? Oh, 18. Thank you. 8, and then 24 with a 0. How does that help? Well, I have just turned an x to the third equation into a quadratic. X squared plus 6x plus 8. Okay. Does x squared plus 6x plus 8 factor into x plus 4 and x plus 2? So the other two roots are -4 and -2. So the problem will say, given a real zero, determine all other real zeros and write the polynomial in terms of a product of linear and or irreducible quadratic factors. So you need to state the roots, and you also need to state all of the linear or quadratic, if it doesn't reduce, all of the factors. What are the factors of that x to the third equation? X minus 3, x plus 2, and x plus 4. So all I have really done is taken an equation or a number, say 30. So find all of the factors of 30, and I know that one of the factors is 5. One of the answers is 5. So I take 30 over 5, and I get 6. Does 6 factor? Into 2 and 3. So my answers are 5 and 2 and 3. So we're doing factoring just like we have with numbers, only we're using a polynomial. Okay, so let's try another one. 3x to the third minus 14x squared plus 7x plus 4. And I know that one of the roots is -1/3. So I put -1/3 in the box. And then I list all of the coefficients. 3, -14, 7, and 4. Drop the 3. -1/3 times 3, -1. -15 times -1/3, 5. 12 times -1/3, -4. How do I know I did that correctly? We ended up with a remainder of 0. It has to be a remainder 0 because they told us that one of them is, in fact, a root. So that gives me 3x squared minus 15x plus 12. Can I make that any easier? Divide by 3. So you end up with x squared minus 5x plus 4. Does that factor? X minus 4 and x minus 1. So my roots are -1/3 and 4 and 1. So what are my... Oh, good. Let me write it out the other way first. X plus 1/3, x minus 4, and x minus 1. But I'm missing something. I'm missing that 3 that I pulled out of here. You could put a 3 out front, but Riata, what did you suggest we do? Put it into the one with the fraction. It doesn't really make sense to put it in there, right? So I'm going to stick that 3x in there, and I get 3x plus 1. Yeah, so you could put the 3 out front, but it actually makes sense to put it inside there because we like... If you just do this, then your leading coefficient is going to be 1, but some of your terms will be fractions. And then if you put that 3 in, then you're going to eliminate the fractions. Okay. What about this? X to the 4th minus x to the 3rd plus 7x squared minus 9x minus 18. And we're told that x equals -1 and 2. What are we going to do here? Yes, those are both answers. So you could synthetic divide by -1 and then synthetically divide by 2. Or you could create a quadratic. You could take x plus 1 and x minus 2 and multiply it together and get x squared plus x minus 2 and then long divide it. But I would recommend synthetic division twice. So it doesn't matter which one you do first. 1, -1, 7, -9, -18. So this is 1, -1, -2, 2, 9, -9, -18, 18, 0. Now I knew that was going to work. What should I do next? Synthetic divide again using 2. So drop the 1 on the new equation. Why do I not want to go back and do it again right here? So the whole point is getting rid of the x's until I get down to a quadratic. Right. So if I had, let's say I had 60, and I told you that 5 and 3 work. So 60 divided by 5 is 12, but 60 divided by 3 is 20. That really doesn't help me. Once I divide it once, I want to divide it again so it becomes more simple. So instead of dividing the 60 by 3, I'm going to divide this, and I end up with 4, which is 2 times 2. So we know that both of them are going to work, but the whole point here is to simplify it down to a quadratic equation. So when I synthetically divide 0, 0, 9, 18, 0, so my equation ends up being x squared plus 9. Does that factor? Yes, into, it's not x plus 3, x minus 3. It's not x plus 3 and x plus 3. It's an I. It's x plus 3i and x minus 3i. Why is it not x plus 3 and x minus 3? That would be a difference of perfect squares. And I have a sum of perfect squares. So in this case, it's x plus 3i and x minus 3i. But look at the instructions. Given a real zero, determine all other real zeros and write the polynomial in a term of product of linear and or irreducible quadratic. They don't care about i's in this case. If you end up with a quadratic that does not factor, we just consider it a prime number. So this only has 2 real roots. And what is the factored version of the equation? It's going to be x plus 1, x minus 2, and x squared plus 9. So for today, if the quadratic is prime, if it does not factor using real numbers, then that is just one of the answers. This one, so it probably looks like this. It has a -1 and a +2. It probably looks something like this, where it has a set of imaginary roots. Now, it might not. It might just look like this. But because we ended up with those, chances are it's going to have a wobble in there somewhere. Why don't we graph it and see? You can't always see the irrational or the imaginary roots, but sometimes you can. It just depends on the equation. And because this is so large, we're probably going to have to multiply by some number. So this graph is so steep that I'm going to multiply it by, say, 0.1. And that will bring the minimum up. So I don't know if you can tell. So it's not, x to the fourth equations cannot be parabolas. But this is not symmetric. So it doesn't divide in half. It actually is coming down, and then it has kind of it has this little change. And let's see if I can find that a little bit better. Can you see right here? It sort of has a little weird movement. Oh, thanks. So 1. Okay, let's change this to 0.3. Oh, what did I do wrong? -5. Oh. Yeah, that doesn't work. Okay. Yeah, it's hard to see. But can you see how it's not symmetric? There's this little change right there. Well, that is created by those imaginary roots. So they weren't strong enough. If you set it up right, you can actually make them so they'll create that. But this piece has been turned into something like this, where there's just a little bit of non-symmetry in there. Okay. So your assignment today, 294, 1 through 22. Oh, we're only going to do odds. And I didn't teach you everything. Okay, so just do 1 through 9 today. Wait, what time do we get out of here? Right, I'm going to do odds. So, okay. All right, I'm actually going to finish. I'm going to finish the rest of the assignment. It's not really that long. So, we know how to factor quadratics. Okay? If we have a quadratic equation, we can find the roots. If it doesn't factor, we can use the quadratic formula. What do we do if we have an x to the third or an x to the fourth or an x to the fifth? Well, there is a way to factor x to the thirds, and from what I understand, there are a bunch of different types of cubic equation, and if you can identify the type, then you can identify the solution method. Now, the only one I've ever seen is grouping, which is something you've done before. Other than that, I don't know how to solve them. And it must be really difficult, because we have decided in mathematics that it's much easier to guess than it is to actually solve them. So if I had x to the fourth plus 6x to the third minus 7x squared minus 8x plus 12. Let's think about that. If that number came, hey, stop working, you're going to want to watch this. If that equation came from multiplying factors together. So I have 4 factors. Okay, what do I know about those factors? Not add up, multiply. So they all start with x, right? How do I know it's not 2x or 8x or 12x? Because x to the fourth is created by 1x times 1x times 1x times 1x. Okay? But what do I know about these? So let's call this plus A plus B plus C plus D. I know that A times B times C times D equals 12. That's where the constant comes from. Right. Does that make sense? Because those are the only values that don't have any x's in them, and A times B times C times D has to be 12. Do I know anything about the signs of A, B, C, and D? All I know is that there are an even number of positives or negatives, right? A could be positive or negative, B could be positive or negative, C could be positive or negative, and D could be positive or negative. So here's the important part. Make sure you watch this. Could A equal 5? No. Why not? 5 does not go into 12. Okay? Unless you end up with some kind of crazy, irrational root. But this is called the rational root theorem. If there are fractions, that's a good point. If there are fractions, then this would not be a 1. Does that make sense? The only way to create fractions is to have a leading coefficient that's not a 1. So in this case, there are no fractions. But A can't be 5. Okay, can A equal 7? No, so instead of asking what A could be, or couldn't be, let's ask what could A be? Well, let's start at the bottom. A could equal 1 or 2 or 3 or 4, 6, or 12. That's it. But what about the signs? But could A be negative 2? Could it be 2? Yeah, so we actually say plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, 6, and 12. Okay? Those are the possible rational roots. What does rational mean? Fractions. Rational means fractions, which includes whole numbers. Okay? If I had, that's a bad one, 3x to the third minus 6x squared plus 2x plus 14. Could the answers be fractions? Yes. The answers might be fractions, but could it be 2/5? Why not? Could my factor be 5x minus 2? So does 2 go into 14? Yes. But does 5 go into 3? No. So here's how you find the possible rational roots, and this is called the rational root theorem. The rational root theorem says if all of your coefficients are integers, like we have, the possible rational roots are plus or minus any factor of the constant. So x could be plus or minus 1 or plus or minus, we're looking at the constant, 2 or plus or minus 7 or plus or minus 14. Does everybody understand that? Now, it is possible for this number to be a 3, which would divide all of our possible roots by 3. So plus or minus 1/3, plus or minus 2/3, 14/3. So when I line up all of my roots, or all of my factors, I would have x, 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 plus a, plus b, plus c. A, b, and c have to be factors of 14, right? But one of these is going to be a 3. So it could be 3x plus 2, and then x plus 7, and x plus 1. That's a possibility, right? 2 times 7 times 1 is 14, and 3 times 1 times 1 is 3. Okay, and notice we don't even care what happens in the middle. That does not affect the possible roots. It will affect the actual roots, but not the possible roots. So if I had 6x to the fourth plus 10, what are the possible rational roots? So x equals plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Now, what are the factors of 6? 1, 2, 3, and 6. So now I need to divide all of those by 1 and 2 and 3 and 6, but most of them are going to simplify and we already have them. So do I need to divide everything by 1? No. So 2, plus or minus 1 half, and then plus or minus 2 over 2 I already have. And anytime it simplifies, you will already have it. That's a guarantee. So I don't need to do 2 over 2. But I do need to do 5 over 2. And do I need to do 10 over 2? No, because it simplifies. Okay, now I move on to 3. Plus or minus 1/3, plus or minus 2/3, plus or minus 5/3, and plus or minus 10/3. Now I need to do the 6. Plus or minus 1/6, plus or minus 2 over 6 simplifies. So 5 over 6 and 10 over 6 simplifies. And if it simplifies, you don't even need to check what it is. If it simplifies, it will already be there somewhere else. So if you notice it simplifies, don't write it down. And if you write it down, you're not wrong. That is a possible rational root. You'll just be a duplicate. So possible rational roots are all of the factors of the constant, plus or minus, all of the factors of the constant, and all of the factors of the constant divided by all of the factors of the leading coefficient. So let's look at number 20. We'll do 20 and then we'll do 22. So x to the fourth plus 2x to the third minus 4x squared minus 2x minus 1. This is number 20, but you don't need to do 20, so don't write it. You don't need to write this down. Yeah, I'm going to change it. We're going to change this to odd. Okay. What are the possible rational roots? X equals plus or minus 1, because those are the only factors of the constant. And does this have any fractions? No. So 1 and negative 1 are our only choices. 2 does not go into the constant. So in the end, I'm going to end up with this. It's going to be x, 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 x. And all of these numbers, they're either going to be 1 or negative 1. Because those numbers added together equal, or multiplied together equal negative 1. So you can't do a 2. 2 doesn't go into it. So, yes? Not more negative. There needs to be an odd number of negatives. Okay? So in this case, my constant is negative, which means it's either going to be 1 negative or 3 negatives. Okay, and we'll talk more about negatives later. We're not going to mess with that today. Okay, so we guess. Are we going to guess 1 or are we going to guess negative 1? 1. Okay, 1, 2, negative 4, negative 2, negative 1. Drop the 1. Wait, did I mess up? So 1, 2, 4, negative 4, negative 2, negative 1. So drop the 1. 1, 2 plus 1 is 3. 3, negative 1. Oh, negative 1, negative 3, and -3 and -4. What does that tell me? 1 is not a root. So this did not work. So let's try -1. No, watch. You'll see. When we get to the end, you'll understand what happened. Okay, -1. So -1, or sorry, 1, -1, 1, -1, -5, 5. Oh, did I write this down wrong? Oh, it's a 3. I'm sorry. The constant is a 3. Yeah, I looked at the wrong equation. It's a +3. Okay, sorry. So what are my possible roots? ±1, ±3. So now, here's a trick. If you want to know if 1 works, so you never will actually need to plug in x equals 1. If you add up all of the constants and you get 0, then 1 works. So 1 plus 2 is 3, minus 4 is -1, minus 2 is -3, plus 3 is 3. So 1 works. That's the way to test 1. So you just have to change the signs as you go through. So 1, 2, -4, -2, and 3. Sorry I messed that up. That was really brilliant of me. So 1. Wait, I know it works. Why am I plugging it in? I need a simplified equation. So 1, 2, nope, 3. So this would be 3, -1, -1, -3, -3, and 0. Okay. Now I have a new equation. And what could go into that? Negative ±1 or ±3. Does 1 work? Yes. If you add 1, 3, -1, -3, it works. So I'm going to do synthetic division again. Put a 1 here. Drop the 1. Because I know 1 works. Because it's a duplicate root. You could choose anything you wanted. It doesn't matter what you pick. You'll see in a second. So 4, +3, +3, and 0. Okay. So this right here tells me that x equals 1 is one of the roots. This right here tells me that x equals 1 is a duplicate root. No, you can, but you don't have to. So we end up with x minus 1, x minus 1, and then there will be 2 more. X squared plus 4x plus 3. The roots are x equals 1, so the factors are x minus 1. Does this factor, x plus 1 and x plus 3, so x plus 1 and x plus 3. So now I have x plus 1 and x plus 3. What are my roots? 1, 1, -1, and 3. Or sorry, -3. 1, 1, -1, and -3. Okay? Well, I knew it was going to work. I looked. So there are 3 roots. X equals 1, 1, -1, and -3. Well, when I looked right here, I knew 1 was going to work again. Yeah, you got to keep going until you find all of them. All right. All right, look at number 22. 3x to the third minus 5x squared minus 26x minus 8. What are the possible roots? Plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Does I've never seen anybody do that. Well, and eventually you won't even need to write them down. So we're just making sure you understand what all the roots are. Okay, what else could it be? This one has the factors of 1 and 3, so I need to divide everything by 3. So plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, and plus or minus 8/3. Now, I would not guess a fraction unless you absolutely have to, unless you've tried all the other numbers and they didn't work. Okay, let's look at 1. Does 1 work? If I add 3, -5, -26, and -8, do I get 0? No. So if you add all the coefficients and you get 0, then 1 works. 1 is not one of the answers. Okay? So let's try. What do you want to pick? 4 or -4? Are there going to be negatives in this case? There has to be at least one negative. Does there have to be a positive? No, we could have 3 negatives or 1 negative and 2 positives. So let's guess -4. Now it might not work. I don't know. -4. Okay. 1, -5, -26, and -8. What did I do? Oh, it's 3. I made a mistake. No. So -4 times 3 is -12. That's -17. 4 times 10 is 40, and 4 times 7 is 28. So it would be 68. Is that going to work? Nope. So -4 is not the answer. All right. We'll try -2. 3, -6, -11, 22, -4, 8, and 0. Okay, now here's something really important. I don't need to guess again because I have a quadratic. Okay, listen to this. You continue to guess and find roots until you end up with a quadratic. Or we could guess. We could keep guessing if you don't like factoring. But I now know some of my original guesses don't exist anymore. Well, 4 worked. Or sorry, 2 worked. -2 works. But my new constant is a -4. Anything with an 8 no longer applies because my new constant is a 4. So here is what I have found. I have found that one of them is an x minus 2. One of the other ones gets a 3, but this one times this one equal 4, -4. It is when you factor. So when you find one root, that will eliminate possibilities for the next roots. Okay? If I had x to the 5th, and then plus 24, and I found one of them to be x equals 6, can the next one be x equals 8? No, because 24 divided by 6 is 4, so all of the other roots have to multiply to be 4. Now, we're going to spend a lot of time working on these. So today, you just need to do 1 through 21 odd. That's okay. Just get... No, you have 15 minutes. So 1 through 21 odd, and 11, 14, and 17 are really easy. You just write down the possibilities. Plus or minus 4, plus or minus whatever. So 1 through 9, you're given one root, do synthetic division, and then factor the rest. Or you're given two roots, where you do synthetic division twice and then factor the answer. And then 19 and 20, you list the guesses, and you keep guessing until you find all the roots. Okay, so 1 through 21 odd.